Now we are going to learn the characteristics of gases. So we discussed about what are the characteristics of solids and what are the characteristics of liquids, right? So now we are going to learn the characteristics or special features of gases. What do we have here, children? You all can see this is an empty bottle. It's very clear there's nothing inside this bottle, right? This bottle is empty. But actually, is this bottle empty, children? No. Even though we can't see there's anything in this bottle is full of gas particles. So this bottle is full of gas particles, air particles. We can't see this because air is colorless, but even though we can't see, this bottle is full of air. Understand, children? What can you tell about the shape of this air, children? Is there a particular shape? Now when this air is present in this bottle, it takes the shape of the bottle. It means these air particles, they spread throughout the bottle. Therefore, for these gas or air particles, there's no particular shape, right? Look at this one. Now what is the shape of this container? It's a different shape. So when air present or gas is present in this bottle, it takes the shape of this vessel, this container. Okay, but when air present inside this vessel or this container, they take the shape of this vessel. Understand, children? Now we'll consider about something like a measuring cylinder. If we take an empty measuring cylinder, there's nothing but air particles present. So then what is the shape? The shape of these gases or air present in this measuring cylinder is the shape of the measuring cylinder. Understand, children? Now we will consider the volume of gases. Right? In this case, volume of air. Okay. What can you tell about the volume of air here? What is the volume? What is the meaning of volume, children? You all know volume means the space occupied by a certain matter. Understand? So what can you tell about the space occupied by air particles in this picture, children? So these air particles occupy the entire space over here. Understand? Now when you consider a glass of water, let's say water is up to this part. What can you tell about the volume of this water? The volume is only this much. Space occupied by water particles is up to this much. But when we consider gases, or in this case air particles, even if we try to put this air into a particular container, what happens? It spreads throughout the container. Okay, so if we take a small container, let's say a small bottle, volume is smaller than here because the bottle is smaller. Okay, so let's say there's a particular amount of air particles in this bottle. What if we take a big bottle like this? So the same amount of air spreads throughout the large bottle. Understand? So it is very clear there's no particular volume for these gas particles because they spread throughout the container. Understand? Because of the special nature of gas particles that they can spread throughout the container where it present, okay children, they don't have, these gas particles, they don't have a definite volume or a definite shape. Understand? Now we are going to do some experiments to prove these two characteristics. Right, children? We have to do an experiment here. Now you know what are the steps of an experiment, right, children? So the experiment is find out whether air occupies space. Okay, so next we have to write down the materials, the things we need. We need only two things. We need an empty bottle. You can take a plastic bottle, even a glass bottle, right? We need an empty bottle empty bottle and we need a water basin, right? Basin full of water we need. We need a water basin. So this experiment you can do at home. Okay. So what do we have to do next? Next step of the experiment is method. What do we have to do here? Look at this picture. I told you when it comes to this method, it's very good if you can draw a diagram of what are we going to do. Okay, so we all understand it when we draw a diagram, and it should be a labeled diagram. So it's very clear. There are two diagrams here. First, what do we have to do? We have to take the bottle and we have to immerse this bottle upside down, vertically. You should not tilt, it should be vertical. You have to immerse this bottle vertically upside down in this water basin. Okay, children, do you remember we did something like this before? I hope you remember. Do you remember we took these dry glass with a handkerchief and we did the same? You remember that, right? We are going to do something like that, the same thing. And in the second instance, what you are going to do is, you are going to tilt this bottle a little. Okay, first you are going to immerse this bottle upside down without tilting. It means vertically. Understand? Second, you are going to tilt the bottle when it's under water and we are going to observe. Now I told you, you have to draw a diagram and we have to label it. So we will label these two diagrams. I am going to name this diagram as A and this one B. Okay, and we will label these two diagrams. Now what are these? This is water and basin. This is a basin. In the lab we take a trough. Basin. And this one is the bottle. Right, children? So in diagram A, step 1, what we have to do is, we have to immerse this bottle in water basin vertically and upside down. Understand? And then we have to tilt the bottle. That is the second step. We have to tilt this bottle inside the water. So we will write down that. So first we are going to write step 1. Put the bottle in water basin upside down vertically. Right? Step 2. What you have to do is, you have to tilt the bottle a little, right? Water, as in diagram B. Put the bottle in water basin upside down vertically as given in diagram A. I will write like that. Diagram A. And tilt the bottle in water as in diagram B. Understand? So these two things we have to do and we have to observe what happens. Now we will do the experiment. Right? Okay, children. Now we are going to do this experiment in order to check whether air occupies space. I hope you remember similar experiment we did before as well. We are going to do this as well. This is a second experiment we are going to do in order to test whether air occupies space. So what do I have here? I have an empty bottle and here I have a colored water vessel. Okay. So first of all, I am going to immerse this bottle vertically. So observe what happens carefully. What happens, children? Can you see any water inside? You cannot. Right? So why does this happen? So when we immerse this bottle in water, why can't this water go inside? That happens because this air is, even though you can't see, this bottle is filled with air. Therefore, this air won't let this water go inside. Okay? So, I am going to, while immersing this, I am going to tilt this bottle a little. Observe clearly what happens here. Can you all see air bubbles? What happens here is the air trapped inside this bottle, it comes out. So it means when air comes out of the bottle, this water has enough space in order to go to this bottle. So now I am going to take this out. What can you see, children? You can see this colored water inside this bottle which was empty before. So what is the conclusion that we can come up with? Earlier, when we tried to immerse it vertically, water did not go inside. That is because air trapped inside, it occupies space, right? So when we tilt this bottle, that air goes out nicely, giving space in order for the water to come inside. So I hope you understand that we can come into a conclusion that air occupies space. Right, children? Now, did you see the experiment? Did you observe what happened when I was showing you the experiment, children? I hope you remember what happened, children. So, when you immerse this bottle in water upside down vertically, what happened? Did you see that water enters the bottle? No, right? So, water did not enter the bottle. What happened here, children? When you tilt, I think you remember, you saw two things, right? Number one, air bubbles go out. Air bubbles go out. Then what happens when air bubbles go out? Water enters the bottle. Understand? So those are the observations that we saw. So we will write down those things. So what are the observations? In diagram A, setup A, I'll write. In setup A, water does not enter the bottle. And what is the next one, children? In setup B, when the bottle is tilted, air bubbles go out and water enters the bottle, right? In setup B, when the bottle is tilted, air bubbles come out and water enters the bottle. So in setup A, water does not enter the bottle, and in setup B, when the bottle is tilted, air bubbles come out and water enters the bottle. Now we have to write down the conclusion. What is the conclusion, children? What is the decision that you can come up with after doing this experiment? So you all know that even we can't see in this first setup, the bottle has air in it, right? We can't see that, but this bottle is filled with air particles. It means the space in this bottle is occupied by air particles. Therefore, water cannot enter because that space is already occupied by air. There's no more space for water to go in. Understand? Here what happens? When you tilt it a little, these air bubbles go out. Right? These air bubbles go out. And then what happens? When the air goes out, what happens, children? There's enough space for water to enter. Here, there's no space for water to enter because the entire space is occupied by air particles. Here, what happens? Air goes out as air bubbles, and when air goes out, there's enough space for water to enter. Right? So, what can you decide? What is the conclusion that you can come up with after doing this experiment? Air occupies space. Right, children? We will write that. So the conclusion is air occupies space. Understand? So it's very clear that air occupies space. I hope you understood this one. Right, children? Now we have the other experiment we have to do regarding the characteristics of gases. Find out whether there is a definite volume for air. Okay, we are going to find out whether there is a definite volume for air. What is the volume, children? Volume means the space occupied by matter. Okay, so what do we need here? You all can see. We need joysticks or incense sticks, right? And here we need a piece of cardboard. What is this, children? We need a gas jar. Actually, we need 2 gas jars. Okay, we will write joysticks, a piece of cardboard, and we need 2 gas jars. You can do this experiment at home. You can easily find joysticks and a piece of cardboard. What about 2 gas jars? We can't find gas jars at home, but instead you can find 2 equal any jars, like 2 equal glasses also okay. Right, children? So we'll see how to do this. What do we have here? So this is the way you do the experiment. Okay, we can see this 1 gas jar here upside down, and we have a joystick. You have to light the joystick, and this is the joystick smoke. And here in the second diagram, we can see 2 gas jars connected, right, kept together. Okay, so I will name this one as diagram A and this one as diagram B. So what we have to do here is we have to light joysticks and we have to collect the smoke to 1 gas jar. Now when you light a joystick, the smoke goes up, right? Smoke goes up, and if you keep the gas jar upside down, you can easily collect the smoke. So why do we take this joystick smoke, children? Because it is easy to observe. It is white in color, right? It's easy to observe. Therefore, you can observe the movements and how they spread very clearly. Then after collecting the smoke to 1 gas jar, we need to cover the mouth of the gas jar with a piece of cardboard. Okay, so we have to cover the mouth of the gas jar with a piece of cardboard. Carefully you have to do this. Okay. This is the cardboard. Now you will see smoke like this. So smoke cannot go out when you cover the mouth with a piece of cardboard. After that, what you have to do is you have to keep the other gas jar like this. Okay, and you have to slowly take out this piece of cardboard so that these two gas jars are connected. Okay, children. So, gas jar turned upside down is connected to the other gas jar or second gas jar. Understand? So, we will write that. Light joysticks and collect joystick smoke. Collect joystick smoke to one gas jar. Right? Next one. Keep the second gas jar as shown in diagram B. Understand, children? So, because we have the diagram here, I don't have to write many steps. Understand? So, light joysticks and collect joystick smoke to one gas jar and keep the second gas jar as shown in diagram B. Now, we will do the experiment, right? Okay, children. Now, we are going to learn the properties of gases experimentally. So, what do I have here? I have two jars, right? These are conical flasks. You have to use, in order to do this experiment successfully, you have to use two equal size jars. The same type equal size jars you have to use, right? You can even use gas jars in order to do this experiment. Here I have joysticks. So, I am going to light these joysticks and fill one gas jar with the smoke of the joysticks. So, you all can see these gas jars are colorless. So, here I am going to fill one flask with the smoke of these joysticks. See what happens, children. Now, this jar is colorless. This gets filled with smoke. It becomes white in color. And I am going to close this one. So, what can you tell about the shape of the smoke inside and what can you tell about the volume of the smoke inside? So, the shape of the smoke, now as the smoke spreads throughout the jar, throughout the vessel, you can say that the shape of the smoke is the shape of the vessel. What about the volume? Volume also you can say, because it spreads throughout the vessel, volume is also equal to the volume of this vessel. So, will this remain the same? We are going to see this now. I am going to connect these two vessels now. See what happens. For better observation, I am going to place a dark color background here. Can you all see that smoke in this top jar, it goes to the down one? So, you all can see clearly how this smoke spreads throughout the two vessels. Is it clear, children? So, why does that happen? So, if smoke can, or the gas or air can remain the same place, it should remain here without going here and there. But you can clearly see that it spreads from one place to another place when we connect these two vessels, right? So what can you tell about the shape and the volume of air or gas? So you can say that shape of gas is not definite, right? So gases do not have a definite shape. What can you tell about the volume, children? As this spreads throughout the space it contains, you can say volume is also not a definite value. So what is the conclusion that we can come up with after doing this experiment, children? We can come to a conclusion that air doesn't have a definite shape as well as air doesn't have a definite volume. Right, children? Did you see the experiment? Did you see how this joystick smoke spread through the two gas jars? So what happened here, children? So you collected joystick smoke to one gas jar and then you set the apparatus like this. You kept a second gas jar as it connects with the first gas jar. So what did you see? Earlier, joystick smoke was in only one gas jar, the first gas jar, right? So when you connect the second gas jar, what happened? The smoke spread throughout the two gas jars. Understand? That is what happened, right? We will write down that. Joystick smoke spreads through two gas jars. Joystick smoke spreads through two gas jars. That was the observation. What is the conclusion? What is the conclusion? Now you know that we do this experiment to find out whether there is a definite volume for air. What is the volume? Volume means the space occupied by matter. So in the first instance, what happened? What was the volume of the smoke? The volume of the smoke was the volume of the first gas jar. But in the second stage, what happened, children? So when two gas jars are connected, did the smoke stay in the first gas jar itself? No, it spread through the other one as well. So what can you tell about the volume? Does the smoke or gases, they have a definite volume, children? No, they spread throughout the container. In the first instance, it spreads throughout the first gas jar. When the two gas jars are connected, the smoke spreads throughout the two gas jars. It means there is no definite volume. Understand? So just imagine you have a glass of water here. Okay? If we put another glass like this, will this water spread to the other glass as well? No, it won't. But when it comes to gases or smoke, what happens? It doesn't have a definite volume. It spreads throughout the entire space, entire container. Understand? So the conclusion is air doesn't have a definite volume. It spreads throughout the container. Understand? We will write it. Air doesn't have a definite volume. It spreads throughout the container. Understand, children? Air doesn't have a definite volume. It spreads throughout the container. So what can you tell about the volume of air or volume of gases? It doesn't have a definite volume. What about the shape? There's no definite shape because it spreads throughout the container. It will take the shape of the container. Understand? So, hence, a gas has no definite volume and a gas has no definite shape. Understand? So, these are the main characteristics of gases. Understand, children? Gas has no definite volume and a gas has no definite shape. Alright? So, here we have matter in gaseous state. Some examples here. Day-to-day life, we have to use different gases. Okay? So, we know that even though we can't see in air, we have oxygen. We inhale oxygen. It's very important for respiration. And we send carbon dioxide out. They are also gaseous forms. Look at this, a balloon containing gas. This is one instance. Okay, hot air balloon. So, balloon containing gas. Here in this balloon, gas present. That is one instance we use gas. An oxygen tank containing oxygen. So, what are the instances we use these type of oxygen tanks, children? Yes, I think you remember I explained it in the first lesson as well. So, for patients in ICUs, we use these type of oxygen cylinders. So, the patients who can't breathe easily, they breathe using these oxygen cylinders. And divers use these type of oxygen cylinders because when they go into deep down in water, there's less amount of oxygen present and anyway we can't breathe underwater. Okay, therefore we have to take oxygen cylinder, the divers. And mountain climbers, okay, when they climb up the mountains in the upper atmosphere, the amount of oxygen is less. Therefore, mountain climbers also sometimes take these type of oxygen cylinders. Understand, children? So, it's very clear there are gaseous states and there are different characteristics of gases as well. So, we learn about the characteristics of solids, liquids and gases. Now, I hope it's very clear when it comes to the volume and when it comes to the shape. What are the differences between these solids, liquids and gases? Right, children? So, look at this. Now, you all can fill this, children. What you have to do is the characteristics of solids, liquids and gases. We have 3 columns in this table: form of matter, shape and volume. Now we learned there are 3 states, so 3 forms of matter. What are they? Solids, liquids and gases. Right. Do this now, children. You all can do this without my help. Okay? Right. Now I'll show you how to do this. I hope you did your work as well. You can check my answers also. So when we discuss about the shape, what can you tell about the shape of a solid, children? There is a definite shape. Look at this pen. There is a definite shape. Shape doesn't change time to time. Okay? Definite shape. We will write in short form. Definite shape. What about the volume of a solid? Definite volume present. Volume also doesn't change time to time. Okay? So, solids have a definite volume as well. Okay. What about the second one? Liquids. What about the shape? Do the liquids have a definite shape? No, they don't. They take the shape of the container, right? Therefore, no definite shape. What about the volume, children? Let's say that you measure 100 milliliters of water from one beaker and you put it to another beaker. The volume will still be the same, right? So, definite volume present. No definite shape, but when it comes to the volume, volume is a definite value. Definite volume. Right. What about the gases? What about the shape of gas? No definite shape. no definite shape. Volume, air particles or gases, they spread throughout the container, therefore no definite volume as well, right? No definite volume. Is it clear, children? Solids have a definite shape and they have a definite volume as well, right? Liquids, they don't have a definite shape, but they have a definite volume. What about the gases? No definite shape and no definite volume. Understand? Do you know what are the reasons for these changes? What are the reasons? Now, solids behave in one way, liquids behave in another way, and gases behave in a totally different way. What are the reasons, children? We will see. I will briefly explain this to you. Remember, in the upper grades, you have to learn this again, right? So, I will briefly explain this to you. So, we will take solids. If you take a solid, let's say this is a piece of iron, iron is solid. So if this is a piece of iron, even though you can't see, this piece of solid is made out of tiny particles, tiny solid particles. And remember, these particles are tightly packed with each other. Okay, they are tightly packed with each other like this. Okay, these particles are tightly packed with each other. Solid. What about the liquids? If you take certain volume of liquids, liquids also made out of particles, but they are not tightly packed. Okay, they are not tightly packed with each other. So if you look at these solid particles, only a little space present in between particles because they are present tightly packed with each other, very close to each other. Look at this one. There's more space, right? There's more space. Therefore, these particles are not tightly packed. Understand? What about the gas particles? We'll take a certain volume of gas. Now, this is a liquid. What about gas? What do you think? Gas also made out of tiny particles. Now these gas particles are not packed at all. They move here and there freely. They present far away from each other. Okay? So when you look at the spaces in between particles, in solids, only a very little space present. Right? And liquids, more space present than in solids. What about gases? There's like enough space here for them to move here and there. These gas particles freely move. Okay, children, they are not packed at all. So, because of this tightly packed nature, solids have a definite shape and a definite volume. Okay? What about the liquids? They are not tightly packed like solid particles. They can glide on each other. Right, children? Because of that, liquids, they don't have a definite shape. Okay, but they have a definite volume. Even though they are not tightly packed, they still present close to each other. Compare this with this one. Okay, so they can't freely move like gas particles, but they have space among each other than these solid particles. Because of that, these liquids, they don't have a definite shape, but still a definite volume present. Understand? What about the gas particles? There are enough space in between particles, right? So, no definite shape and no definite volume. These gas particles, they always move here and there freely. So because of this presence of particles away from each other, these gas particles, they have a special characteristic, special nature. That is, children, by applying a special external force, we can make these gas particles come towards each other. Okay, I'm going to explain it again. Now come here. Solid particles, they present very tightly packed, very close to each other. So let's say, children, if we give an external pressure, right, external force or external pressure, can we move them towards each other more than this? It is not possible. They are already tightly packed. Even if we give a special external force or pressure, there's no way to move these solid particles towards each other anymore. Right? Look at the liquid particles. There are only little spaces present in between particles. Okay, so still it is difficult to make them too close to each other by a external pressure. Okay, but gas particles, there's much space in between these particles. Therefore, by giving or by applying an external pressure, we can move these particles as they come close to each other. So this nature is known as, this ability is known as compression. So we call it, we can compress gas particles. Compression means ability to move these gas particles towards each other by applying a special pressure, external pressure, right? Only gas particles can be compressed. Understand, children? So what are the instances we use this compression of gas particles? To fill gas particles into cylinders, in oxygen cylinders, we use this compression. I will draw an oxygen cylinder here. We need to fill oxygen gas to this cylinder. So you know that gas particles, they present away from each other like this. So what will happen? If we use the natural form of oxygen, there will be more space among these particles, and when you consider the entire cylinder, inside this cylinder only a limited amount of oxygen particles will be there. But by applying an external pressure, we can move these oxygen particles close to each other, and thereby we can fill more and more oxygen particles in this. Okay, see? Now when the compression is not there, these particles present far away from each other. But by compression, by applying an external pressure, you can make these particles go towards each other, and thereby you can fill more and more oxygen particles into this cylinder. Same goes with LP gas cylinders. Now LP gas you use in day-to-day life in gas cookers. LP gas means liquid petroleum gas. Same theory is applied in LP gas cylinders as well. Okay, children. So compression or ability to compress is a special nature of gases. We cannot compress solids and we cannot compress liquids. Okay, children. Only gas particles can be compressed very easily. Understand? Right. Right, children. We have an assignment. Categorize the things in your kitchen as solids, liquids and gases. Write them in a table. Very easy. You all can do this. Right? Pay a visit to your kitchen and you can write down what are the solids you can find, what are the liquids you can find, and what are the gases you can find. I will also show you how to do this. You can write many other examples, okay? I am going to write only a few examples here. So, what are the solids, liquids and gases we can find? I'm going to write here solids, liquids and gases. What are the solids in the kitchen? You have cups, plates, pans, those type of things, cupboards, all these things are coming under solids, right children? You can write other examples as well. I'm going to write pans, cups, plates, knife. These are solids. Okay children, what are the liquids? The main liquid, we have a water tap, therefore water. Water. What are the other liquids? We have cooking oil, right? What else? Cooking oil, we have coconut oil or vegetable oil, any kind of cooking oil. And what else? Coconut milk. Coconut milk and fresh milk, right? These are the liquids and many other liquids are there. Okay, gases. Now earlier I mentioned you LP gas, gas cylinders. So we can use liquid petroleum gas or LP gas. Or sometimes in some houses they use biogas as well, right? Biogas is also example. Okay, so you all can do this by yourself. I'm pretty sure you will make a longer list than mine, because when you actually go into the kitchen and by looking at the things in the kitchen, you can find so many other things as well. Okay, right. Now children, so far we discussed about the characteristics of solids, liquids and gases. So in this lesson, we are going to pay special attention towards solids. And now we are going to learn specific characteristics or special characteristics of solids. Right children? We will see specific properties of solid matter. Now I told you when we discuss about solids, liquids and gases, in this lesson we are going to specially discuss about the special features or special characteristics of solids, right? So we have an experiment to do. Experiment, find out the properties of solids, different properties of solids, right? What are the materials? Now you can see we have number of solids here. We need these types of number of solids to do this experiment. Okay. So what is this? It's an iron sheet or sheet of iron. Iron sheet. Here we have a copper sheet. And nails. Iron nails are there. Iron nails. And pieces of chalk, rubber bands, and a piece of charcoal, and cotton wool, a piece of clay, flour, and pieces of wood, and an elastic tape, and here we have sand and a hammer. Right children, we have number of solids here and a hammer. What are we going to do in this experiment children? We are going to find what are the special properties of solids using these materials. So what are we going to do here? How to check what are the special properties of solids using these things? There are different ways. Now we have given a hammer here, right? We can beat each substance, each solid with a hammer, and we can check, we can see what happens. Some materials with our fingertips and we can feel it. Okay, and some of these things we are going to pull into the either side, right? And we are going to check what are the special properties, right? we will write down this. Okay, what are we going to do? Touch the above materials. Touch the above materials with your hands. And pull them to either side. And you have to, using this hammer, you have to beat each material, right? Beat the materials with the hammer. Right? So by doing these things, we can check whether there's a special property in each material, each solid or not. Now we will do this experiment, right? Okay, children, by now we all know that things in the environment, there are two types of things, matter and non-matter. And further we know that matter can be divided into three parts, or there are three states in matter. What are they? Solids, liquids and gases. So solids, liquids and gases can be considered as the three states of matter. So we are going to learn about these solids further, as I explained to you. So here I have some different types of solids here. We are going to learn what are the special properties, what are the specific properties of these solids. So you all can see I have some solids here. I have some sand, some wheat flour. Here we have a piece of cardboard and a piece of sandpaper, a piece of paper, a piece of cotton, and here we have a piece of charcoal and a mothball, and also known as naphthalene, and a piece of chalk we have here, piece of clay, and we have a piece of plastic and a polythene, right? We have a rubber band and another piece of rubber we have, and also we have here piece of copper wire, piece of copper sheet, piece of aluminium sheet, and a piece of zinc sheet, and we have a iron nail. So we are going to see what are the special properties of these solid substances. First I am going to take this sand and I am going to check what I can feel when I touch it. So it's very rough. You all have touched sand, right? So it's very rough. I can feel to my fingers it is rough. And then I am going to take this flour. When I touch this flour, I can feel it's really soft, right? It's very, very smooth, not like this sand. And then I am going to take this piece of cotton. So when I touch this piece of cotton, I can feel that it's very smooth. You all have experienced that before. And when I touch this piece of clay, again I feel it's smooth. But when I touch this sandpaper, it has a rough surface, right? It is rough. And when I take this piece of paper, that also has a smooth surface. So what is this, children? Now you all understand when we touch something, some surfaces you feel it's very smooth and some surfaces you feel very rough. So this is because of a special characteristic, special property called texture. So texture means what you feel when you touch something. So texture, there are two different types of textures, rough and smooth. So you all understand now when we consider about these solid substances, texture is one specific characteristic, one specific property. So then I am going to take this piece of cardboard. Now we'll see what happens when I pull this piece of cardboard into either side. What happens, children? It tears into pieces, right? So then I am going to take this piece of paper. What will happen? You all know it also tears. But if I take this rubber band, you can see it will not break. It stretches really nicely. Okay, it's very stretchy. Okay, so I can pull it into either side. When I release, it will come back to the normal size. Okay, what about this copper wire? When I pull this copper wire, nothing happens. It will stay in the same way. Okay, so this is also another property, children. So this is also happens because of another nature of these solids. This nature is known as elastic nature. So some of the solid substances, when you pull, they break or they tear. If it's a paper, if it tears, so it breaks. But some other substances, some other solid substances, when you pull it to either side, they nicely stretch. This happens because of this special property called elastic nature. Now we are going to study another property of the solid substance, children. So you all can see I have a hammer here. I am going to take some of these substances and I am going to hammer them. First I am going to take this mothball. What happens? It breaks into pieces. I am going to take another substance as well. This time I am going to take a piece of charcoal. What happens, children? This also breaks into pieces. Next I am going to take this piece of chalk. You'll see what happens. You all can see clearly that also breaks into pieces. We will check with some other substance. Now I'm going to take this piece of copper sheet. You can see it's brown in color, copper color. So you all can see, children, what has happened here. It doesn't break into pieces, right? It doesn't break into pieces, but it remains as a sheet, okay? Then I'm going to take this piece of aluminium. Okay, children, here this also doesn't break into piece like that mothball or piece of charcoal, right? This also remains as a sheet. So I'm going to take this piece of zinc. This is a bit harder than this aluminium. They look alike. I'm going to break that as well. I'm going to hammer that as well. So look at this, children. Again, it doesn't break into pieces. This one also remains as a sheet. So it's very clear, children, some of these substances, when you beat them with a hammer, some of them will break into pieces and some of them will remain the same, right? So if a certain substance break into pieces, that nature is known as brittleness. Okay, so when you beat with a hammer, if a certain substance breaks into pieces, that nature, that property is known as brittleness. So if a certain substance doesn't break into pieces when you beat with a hammer, that special property is known as malleability. So the substances with malleability, they will not break into pieces when you try to beat them with a hammer. Instead, they will turn into a thin sheet, just like this copper wire, right? So that property is known as malleability. Okay, children? So there are other substances that we could not use. Now this one, I can use this piece of polythene to check texture. So when I touch this one, it is smooth. Okay, and this piece of plastic also, when I touch, it is smooth. Okay, so both of these substances have smooth texture. I told you what you feel when you touch with your fingers, what you feel is known as texture, either smooth or rough. So we learned different properties of solid substances. Do you remember what we learned, children? we learned about texture. So under texture, we learned about smooth texture and rough texture. And we learned that there are some substances, when you hammer it, when you try to beat it with a hammer, they break into pieces, and that property is known as brittleness. And some other substances, they don't break into pieces, that is known as malleability. Okay, and when you stretch some substances, they break into pieces, so they tear, and other substances, they will stretch nicely. That is because of this elastic nature. So I hope you understand that. Right, children? So you observed the experiment, right? What did you see when we were doing the experiment? You saw that when we beat the materials with the hammer, some materials, they break into pieces very easily. And some other materials, did they break? They did not. They become thin sheets very easily without breaking into pieces. What happened when you touch the materials with your hands? Some of them are very smooth, some are very rough, right? And what about pull the materials to either side? Now, you remember, I tried to pull the piece of cardboard to either side. What happened? It tears. But what about the elastic rubber band? It stretches. Okay, so there are special qualities. These are the special qualities or properties of these different materials, solid materials. We will write down the observations. Observations. There are different observations. We are going to write one by one now. Some materials easily break into pieces. And some materials, they don't break, but they become thin sheets. Some materials become thin sheets when we beat with the hammer. Some materials stretch very easily, and some materials, they do not stretch. Stretch easily. Some materials do not stretch. And what is the next one? Some surfaces, some materials, when you touch, they are very smooth. Some materials are smooth. Remember the piece of cotton? And some materials are rough. Right, children? Some materials are rough. I hope you remember the sandpaper. So there are different properties that we can observe by doing this experiment, children. When you discuss about these different observations, there are specific names that we can give. I explain it in the experiment as well, you remember, right? So some materials easily break into pieces. What is this nature? What is this property? This is known as brittleness. We will write down. Okay, this property of solids is known as brittleness. Brittleness. Some materials become thin sheets. What is this property, children? What is it called? Malleability. Malleable, right? Or malleability. Malleability. And some materials stretch easily because of its elastic nature. Some materials are elastic and some materials are not. There are some materials that stretch easily because of its elastic nature, and some other materials do not stretch. They are not elastic, right? And some materials are smooth and some materials are rough. So this nature of property, that what you feel when you touch a certain material with your fingers, is known as the texture, right? Texture. So some materials have a smooth texture and some have a rough texture. Right, children? So these are only some properties, children. There are many other properties as well. Look at this table given. So all these things in the same table, we have all the properties. Now look at this column. Now we all have to fill these two columns. The meaning is given. Understand? Physical properties of solids. Meaning. Examples. What is the first one? The property of resistance to scratch, abrasion and cutting is known as hardness. Hardness differs depending on materials. Now you know that if you take a piece of coal, it is very hard, right? It is very hard. Even a piece of iron is very hard. And there are some other materials like a piece of clay, they are not hard. Okay, so there are some materials, they resist to scratch. You can't scratch easily, you can't break easily. This property of solids, property of resistance to scratch, abrasion and cutting is known as hardness. Understand? So hardness differs depending on materials. As I told you, some materials are very hard, some materials are not that hard. Okay, so what is the property here? Hardness. Hardness. Here we have to write the examples. What are the hard things? Most of the metals are very hard, right? Like iron. Iron is a very hard substance. Because it's very hard, we use this iron to make different machines, vehicles, right? Because they're very hard. But when we take the hard substances, do you know what is the hardest substance in the world? You have any idea? That is diamond, right, children? Diamond. Diamond is the hardest substance in the world. Understand? Where do we use diamond, children? You all know, to make jewelry, to make earrings, rings, necklaces, right? We use diamond. Apart from making jewelry, what are the other instances of using diamond? Now I told you diamond is the hardest substance in the world. Because of this, we can use diamond to cut glass, right? Without breaking the glass, neatly we can cut glass using diamond. Understand, that is another use of diamond. Okay, children? We'll move to the second one. The ability of a metal to be drawn into thin sheet without breaking by hammering or rolling is known as malleability. We discussed about this, right? Remember? Some materials become thin sheets, malleability. Okay? So that property of the ability of a metal to be drawn into thin sheet without breaking, thin sheet without breaking by hammering or rolling is known as malleability. Malleable, right? So what is the physical property here? Malleability. Malleability. Okay. What are the substances that are malleable? Most of the metals are malleable, right? So iron, aluminium, copper are examples. Okay, children. Third one. The ability of a metal to be drawn into thin wires without breaking is called ductility. Now, this is a new term. We did not learn ductility under these steps. Okay? So, ductility means the ability of a metal to be drawn into thin wires without breaking is called ductility. Right, we will write it here. Ductility. Ductility. And again, ductility is a special property or specific property of solids, and most of the time metals show ductility. Understand? So you can make copper wires, aluminium wires, like conductive wires. You can use this property to make those conductive wires, right? So copper and gold, silver as well. Gold, aluminium. Those are the examples. Okay, the next one. The property of increasing the length of a material by a force of stretch. When you stretch, some substances, some materials, they increase the length. Right? What are the substances? Do you remember the rubber band? What happens? It stretches nicely. That property is known as elastic nature. Right? Elastic nature. Elastic nature. What are the substances with elastic nature? Rubber bands. Rubber. Elastic. They are coming under the substances with elastic nature. Okay, children? The next one. Tendency of a material to break under a small force. Did we learn this one in the experiment? We did. Some materials easily break into pieces when we hammer them. Brittleness. What is the name? Brittleness. Tendency of a material to break under a small force is known as brittleness. Brittleness. What are the substances that are brittle? In the experiment we observed chalk. What else? Glass, charcoal, they are all coming under brittle substances, right? And the next one. Feel of surface, rough or smooth. When we touch, what do we feel? That nature is known as texture. Rough or smooth. What are the examples, children? Okay, tell me for rough substances, examples. Sand, sandpaper. Right, I'll write sand here. And smooth substances. Smooth substances, what are the smooth substances? Cotton wool, powder, they are coming under smooth substances. Right, cotton wool. Right, children? So is it clear? When we take these solid substances or solid matter, there are specific properties, special properties of the solid matter. Okay, so what are those specific properties of solid matter, children? Hardness, malleability, ductility, elastic nature, brittleness, texture. In the other grades, you will learn some more properties of solid substances. Okay, children? So these properties, these special characteristics of solid substances are very useful in our day-to-day life. Now we are going to see what are those useful instances, right? Applications of solids. Now I told you we use solids in our day-to-day life because of their special properties. Specific properties, right, children? So we learn what are the different types of specific properties that they have, like malleability, ductility, hardness, like. Okay, so look at this picture, children. What can you see here? It's a house. Look at this house carefully. You can see the roof, the walls, the windows, doors, and the floor. It's a very complete house, right? So when you consider this house is full of different types of solids, isn't it? It has different solids. You can see in the roof there are roofing tiles, right? Walls are made with bricks and cement. and these window frames are made with wood, and window panes are made with glass, right? So different solids are here. Why do we have to use different solids under different part of this house? That is because of when we consider about the physical properties or specific properties of solids, they are different from one type of solid to another type of solid, right children? So for example, we use for these windows, we can use glass. Why? What is the reason? Because of the transparent nature. Because of the transparent nature, daylight can come into the house. What if we made it with metals? You can't get any daylight when the windows are closed. Okay, so because of special properties or specific properties, solids are applied in day-to-day life in different ways. We will write down this one, children. Now I am going to write a few of them. We will start from the roof. Roof is made with roofing tiles, right? Roofing tiles are made with clay, so you can use this clay to make different shapes of roofing tiles, right? And here you can see windows. To make the windows, you can see to the frame, you can use wood, and here even glass. Okay, wood and glass. So wood is hard and glass is transparent. So to make the frame, you use wood because it has to be strong. Okay, and to get daylight, you use glass. Okay, what about the walls? Walls also made with bricks and cement. That is because bricks and cement are very hard. Walls should be very hard. Okay, the house should be a strong one. That's why walls are made with bricks and also cement. So likewise, when you look at this picture, you can see now here you can see floor tiles. Floor tiles also made with cement or clay, right? So it should be very hard. Likewise, there are different solids used in different parts of this house because of the specific properties they have. So to understand this better, we will do one example, right children? We have a table here. We have to fill this now. You all can start now to do it in your way, or even you can look at my one as well. Okay? So we have to write what is the application, what are the materials, what is the property, why do we use that type of material for that application, right? So I will start with to make tires in the vehicles. Tires. What do we use to make tires, children? We use rubber. What is the special property of rubber? Why do we use rubber to make tires? Why can't we use something like metals, like iron or aluminium? That is because it's too hard. It's very uncomfortable. If the tires are made of something very hard, it's very uncomfortable for the passengers, right? That's why we use rubber, because of its elastic nature. Elastic nature. What are the other parts of a vehicle? What about the engine of a vehicle? It should be very strong, right? Engine, vehicle engine, and even the body of the vehicle should be very strong. Therefore, we use materials iron. What is the property? Hardness. As I told you, you can write your own examples, okay children? What am I going to take as the third one? I will take to make bed sheets. Bed sheets or bed linen. What do we use to make very comfortable bed linen? What do we use? Cotton thread. Why do we use cotton thread? Because it's very smooth and comfortable, right? So cotton thread. So we can use, because the property is smooth texture. Right, we discussed about smooth texture. Next I will take to remove paint on walls. Now let's say that we are going to paint our house with a different color. So in that case, we have to remove the remaining paint on walls, right? How do we remove it? We can use a piece of sandpaper. Why do we use a piece of sandpaper? Because it is rough, okay? To remove paint, you can use sandpaper. Because it's rough texture. So when you look at different things in the environment, different materials are there, you can see why we can use this type of materials. There's always a reason because of their special physical properties, okay? Next I will take to cut glass. What can we use to cut glass? I told you the hardest substance in the world, that is diamond. Why do we use diamond? Because it's very hard. Its hardness, property is hardness. And the next one, to make conductive wires. Okay, to make conductive wires, what can we use? Copper wires, aluminium wires. We use them because we can make thin wires using those type of substances. What is that nature called, children? Ductility, right? To make conductive wires. Conductive wires. Most of the time we use copper, aluminium as well, because of ductile nature, ductility. To make jewelry. What do we use? Gold, silver, okay? We use gold and silver and even platinum. Why do we use them? Because we can make different shapes. What is it called? Malleability. Without breaking, we can make different shapes. That nature is known as malleability. Cooking pans. To make cooking pans, we use aluminium. Why? Because we can make them into shapes using the property called malleability, right? Malleability. What about machine parts? Machine parts? Machine parts should be really hard, okay? So most of the time we use iron. That is because it is very hard, because of hardness. What else can we take here? Pacifiers. Pacifiers for the babies. So pacifiers, what do we use? Rubber, because it is elastic. Elastic nature. Right, children? So we wrote 10 instances where we use different types of substances, different types of solids in our day-to-day life, right? So I hope it's very clear when we look at these different materials, they have specific properties. Because of those specific properties, we can use different materials, different solids to make different substances. Understand, children? Right. Right, children. So we completed the lesson. Now, do you remember what we learned under this lesson? Shall we go through the summary of the lesson, children? Okay. Our environment consists of different things. In the first lesson also we discussed about the environment. As I told you, in this second lesson also we discussed about the things in the environment. But we look at the environment in a different way, not like the first lesson, right? The components of the environment can be categorized as, what are they? Matter and energy. Give me another name for energy, children. Yes, non-matter, right? So the components of the environment can be categorized as matter and energy or non-matter, right? So what are matter? Things with a mass and occupy space are known as matter. So matter has a mass and matter occupies a space in the environment. What about the energies? They don't show these characteristics, right? Things without a mass and do not occupy space are known as energy. Different energy we discussed about. Light energy, heat energy, sound energy. I hope you remember these things. And matter can be classified as solids, liquids and gases. So we further discussed about matter. Matter has 3 states or 3 forms. What are they? Solids, liquids and gases, right? And a solid has a definite shape and a definite volume. Now when it comes to solids, liquids and gases, their properties are different. Right, children? So a solid has a definite shape and a definite volume. What about a liquid? A liquid has a definite volume but no definite shape. Right? What about a gas? A gas has no definite shape or a definite volume, right? And the properties of solids are important in our day-to-day needs. So we further discussed about the solid state of matter and we discussed about specific properties or special properties of solids, and we learned that these special properties are very important to do our day-to-day activities. So I hope it's very clear. So we are done with the lesson. Now what do we have to do? We have to practice what we have learned so far. How do we do that? Yes, we have to do the exercise. Now we will start to do the exercise, right? Now we are going to do the exercise given in the textbook. Okay, you all can do this before me, children. So when I explain this one, you can check whether your answers are correct. Okay. Question number 1. Fill in the blanks with suitable words. Things with a mass and occupy space are known as, what are they, children? Yes, that is matter. Things with a mass and occupy space are known as matter. Matter. Right. Next one. Light is an example for, what is light? Matter or energy? It is an energy because light doesn't have a mass and light doesn't occupy space. Therefore, light is an example for what? Energy. The 3 states of matter. What are the 3 forms of matter? Solids, liquids and gases, right? The 3 states of matter are solids, liquids and gases. It's very easy, right? A solid has a definite and a definite blank. Solid has a definite shape and a definite volume, right? A solid has a definite shape and a definite volume. What has a definite volume but no definite shape? Definite volume is there but no definite shape. What is that, children? Now solid has definite shape and volume both. And liquids has a definite volume but no definite shape. A liquid has a definite volume but no definite shape. Next one. Occupies the whole volume of the container. Now you all know this one. We did an experiment as well. A gas occupies the whole volume of the container. A gas. Right, children? Moving to the next one. Number 2. Underline the correct answer. A material with the property of brittleness. What is brittleness? When we beat with a hammer, there are certain substances, they break into pieces, and this nature is known as brittleness, right? So what is brittle from this list? Glass, rubber, copper. Rubber is not brittle, copper is not brittle at all because it becomes a thin sheet, but glass breaks easily. Therefore, glass. Number 2, a material with a higher hardness. Right, increased hardness is clay, diamond, rubber. You all know the answer. Diamond is the hardest substance in the world. Therefore, a material with a higher hardness is diamond. A material with a soft texture is a smooth substance. What is that? Gravel, very hard. Clay, soft. What about coal? Coal is also hard. Therefore, a material with a soft texture is clay. Right? A material suitable to make wires. They are indirectly asking about the ductile nature or the ductility. There are substances that we can easily draw into thin wires. That is known as ductility. Right? So, materials with ductile nature. Okay, a material suitable to make wires is most of the time metals. Okay, rubber, copper, graphite. So, the answer is copper. Copper wires are very common. A material with an elastic nature, when you stretch it increases the length without breaking. Plastic, cotton clothes, sevap rubber. Rubber is always very elastic, right? Answer is sevap rubber. Okay, children, moving to the next one. Write down the materials used to make the parts of a vehicle. Then write the physical property of each material. Now we take a vehicle. There are different parts like tires, its body and its engine, its shutters, right? So we use different materials because of different properties of these materials. So we will write down this one. The best way to write down this one is using a table or tabulate it. We will write part of the vehicle. And then we are going to write what is the material used. Materials and property. You all can do this very easily. Now you know how to make list like this with different properties. I will show you some examples. I will start with the engine. Part of the vehicle, engine. I told you engine should be very hard. Therefore, we use iron. Right? Iron because of the property of hardness. Right. Next one, body of the vehicle, vehicle body. Vehicle body. Again, the body should be hard, and at the same time we can use iron because it is malleable. We can make different shapes. Okay. So, iron, malleability and hardness both. Malleability and hardness. Okay, tires. What do we use for tires? We use rubber. That is because it is elastic. Elastic nature. Okay, children. So you can write other examples as well. I wrote only a few examples. Okay. You can write the other examples as well. Understand, children? What are the other examples? Maybe for shutters you can write. You can use glass because you can see through. It is transparent. Okay. Likewise, you can write other examples as well. So, we finished the exercise given in the textbook, children. But in order to practice this lesson again and again, we are going to do some additional exercises as well. Okay? Right. Additional exercises 1. Underline the correct answer. We have 4 answers given. We have to select the most correct answer. Okay? 3 characteristics are given here. Being low weight, ability to spread wherever there is space, can be compressed. Out of the properties given above, the properties of air are properties of air. Out of the properties given above, properties of air. Being low weight, when we discuss about solids, liquids and gases, yes, air and other gases, they have a less mass. Okay, therefore being low weight is correct. Ability to spread wherever there is space. Yes, that is a specific property of gases. Okay, so air is a mixture of gases. Therefore, that is right for air. Can be compressed. Now, do you remember I told you that air and other gases, they have this specific nature that they can be compressed. Why, children? When we take air particles, they present far away from each other. Okay, there are gaps in between these air particles and therefore using an external pressure, we can compress these particles. Therefore, this is also right, can be compressed. So, what is the answer? A, B, C, all. Fourth one. Understand? Number 2. Materials have the ability of forming into thin sheets without breaking when beaten with a hammer. This property is known as, what is this? Malleability. Okay, metals have the ability of forming into thin sheets. It means they are malleable. Malleability. What is brittleness? They don't become thin sheets. Instead, they break into pieces. Ductility means ability to make thin wires. Elastic nature, when we stretch something, it increases the length. Okay. So, the ability of forming into thin sheets without breaking is known as malleability. Okay. Number 3. The pair of substances that can be transformed into all solid, liquid and gas states easily is. Right? Different pairs are given. Wax and water. Water and mercury. Copper and iron. Wax and gunpowder. Okay, children. Look at the first pair. Wax and water. Now, water we all know, it can be found in all solid, liquid and gaseous states. Solid state of water is ice. Gaseous state of water is water vapor. Normally, day-to-day life, we drink water, that is the liquid state. What about wax? Let's take a candle. Now, candle is solid. But when we light the candle, you can see it becomes liquid. And when we light the candle, the flame has gaseous wax. Okay. So, this answer is correct. What about water and mercury? Water can be found under all 3 states, but mercury, it's a liquid substance. It's difficult to turn into solids. And copper and iron? They are solids and they are metals, and at the same time, it's very difficult to convert them into liquids and gases. Here it says easily. Okay. Wax and gunpowder. Gunpowder is not the answer. Therefore, the most correct answer is wax and water, because it says that can be transformed into all three states easily. That is wax and water. Number 4. The pair of substances which are malleable. Now, what is malleability? We discussed earlier as well. Metals have the ability of forming into thin sheets without breaking. That property is known as malleability, right? So, what are the substances that are malleable? I explained you most of the metals are malleable. Okay. So, here we have plastic, rubber. Can we make this rubber into thin sheets or even plastic? No. Plastics will break. Okay. Water and mercury? No, we cannot. What about copper and aluminium? Yes, we can, because they are two metals. Water and iron? Iron is malleable, but water is not. Therefore, the answer is copper and aluminium. Right, children? Number 5. The roughness or smoothness that is felt when a substance is touched is known as. When we touch something, we feel whether the surface is rough or smooth. What is that nature called? That is known as texture. That is texture. Okay. Number 6. The property of resistance to scratch, abrasion and cutting is known as. What is this quality, children? That is known as hardness. Only hard substances show these properties. Okay. Hardness. Texture is what you feel when we touch. Malleability is things become thin sheets, forming to thin sheets when we hammer. And ductility means substances turn into thin wires. Okay, so here the answer is hardness. Things with a mass and occupy space. What is this? Matter. Things with a mass and occupy space are known as matter. Energy means things without a mass and do not occupy space. Solids and gases, they are forms of matter. Okay, states of matter. Therefore, answer is matter. Light energy and heat energy. Two energies are given. Light energy and heat energy occupy space. Energy? Light energy occupy space? No, that is not. Do not have a mass. Do not have a mass is right, but they don't occupy space. So, that is not the answer. Do not occupy space. That is correct. Do not have a mass. It is right. We'll anyway go to the third one. Occupy space? No. Have a mass? No. That is matter. Right? Do not occupy space? That is right. Have a mass? No mass. Right? So, answer is number 2. Energy, do not occupy space, do not have a mass. Okay. Number 9. Read this carefully. Each of these containers has 25 milliliters of water in them. The conclusion that can be drawn by observing this diagram is that, look at these 3 things. Each container has 25 milliliters of water. By looking at this one, by doing this experiment, what is the conclusion that we can come up with? Number 1, a liquid has a definite shape. This statement is wrong, children. Does a liquid have a definite shape? No, it takes the shape of the container. Look at this one. Now, 25 milliliters of water in this round bottom flask is the shape of this container. And these 2 shapes are also different, right? A liquid has a mass. Is it correct or not? It is correct. But by doing this experiment, that is not what we can prove. So, be very careful when you write the answers. So, it looks like a correct sentence, correct statement, that is true. But that is not what we can show by doing this experiment. Understand? Therefore, even though it is a correct sentence, correct statement, this is not the answer. a liquid has the ability to flow. Now that statement is also correct. The liquid can flow from one place to another place. Why? Because liquids, they don't have a definite shape. But by doing this experiment, we can't prove this. Therefore, even though the statement is correct, this is not the answer. Last one, a liquid takes the shape of its container. Yes, we have 3 containers of different shapes, the same amount of water. So it's very clear that even though the same amount of water present in each container, these 3 different amounts of water have different shapes. They take the shape of the container. Understand? So that is the answer. A liquid takes the shape of its container. Right? The substance without a definite volume or a definite shape. Now we'll go from the beginning. When it comes to solids, solids have a definite shape and a definite volume. What about a liquid? Liquids do not have a definite shape, but they have a definite volume. What about a gas? A gas doesn't have a definite shape or a definite volume. So the substance without a definite volume or a definite shape is, what is that? It should be a gas. We have 4 answers. Dyes. Dyes is a type of solid. Water. Water is a liquid. Mercury. It's also a liquid. What about this one? Air. Air is mixture of gases. Therefore, here the answer is air. Right? Number 11. The properties of a rubber band, an aluminium sheet and glass respectively are in order. A rubber band number 1, an aluminium sheet number 2 and glass number 3. Right? Properties of these 3 substances respectively are. So under each answer, 3 properties are given. The first property should be the property of rubber band. The second property should be the property of aluminium. And the third property should be the property of glass. So we'll go to the first answer. Brittleness. Is rubber band brittle? No, rubber band is not brittle. Therefore, that is not the answer. Second one, elastic nature. Rubber band, yes, it is elastic. We can stretch it. Aluminium sheet. Aluminium is a type of metal and here malleable. It is malleable. Metals are malleable. Glass, brittleness. That is also correct. If we try to beat a piece of glass with a hammer, it breaks into pieces. Therefore, this answer is correct for now. But I am going to go to the other answers as well. Number 1, elastic nature, rubber band. Right. Number 2, brittleness. Aluminium sheet? No. It doesn't break, but it becomes a thin sheet. Therefore, this is not the answer. Number 4, ductile. Rubber band? No. Rubber bands cannot form into thin wires. That is a property of most of the metals. Therefore, it's sure that answer is the second one. Number 12. The property of increase in the length of materials by force of stretch. What is this nature? Elastic nature, elasticity, right? So malleability, it means when you hammer a certain substance, it forms a thin sheet, right? Elastic nature is the answer. Ductility, drawn into thin wires. Brittleness, breaking into pieces. Okay, so the answer is elastic nature. Understand? Number 13, the substance that shows brittleness. Now, we all know brittleness means when we beat with a hammer certain substances, they break into pieces. This nature is known as brittleness, right? So, which substance is brittle? Glass? Yes. Rubber? No. Iron and copper? They are metals. They are malleable. Therefore, answer is glass. Number 14. Select the correct statement about gases. Gases has a definite shape. There's no definite shape for gases, right? Has no definite volume. That is right. This is wrong. This is right. Does not occupy space. No, it's not, because gas is a type of matter. Gas is a state of matter. any matter occupies space. And we did some experiments to show that gases also occupy space. Okay, therefore this is also wrong. The type of energy, no. Gas is a type of matter. Therefore the answer is has no definite volume. Right? The property that does not belong to solids is, does not belong to solids, cannot flow. Now it's asked, does not belong to, does not. Cannot flow. Can solids flow? They cannot. Therefore, this is not the answer because they ask the property that does not belong. This is a property of solids. Solids cannot flow. Has a definite volume? That is a property of solids. All solids, they have a definite volume, right? Can be compressed. What is the substance? What is the state of matter that we can compress easily? That is gas. Can we compress solids? No. Why? What is the reason? Because solids are made out of particles which are tightly packed with each other. There's no way to compress this by external pressure. There's no space to compress. Okay, they are already tightly packed. Understand? Therefore, this is the answer that does not belong to solids. Can be compressed is wrong. Has a definite shape. It is a property of solids. Okay, children? We'll move to the next one. Additional exercises 2. If the following statements are correct, put a tick, and if wrong, put a cross within brackets. A solid has a definite shape, definite mass, and definite volume. Correct or not, children? It is right. A solid has a definite shape and volume and a definite mass as well. Right? It is correct. A container is not required. A container is not required to store a solid. It's true. Why? Because solid has a definite shape and a solid doesn't flow. Therefore, you don't need a container. It is right. A liquid has a definite mass and a definite volume as well as a definite shape. It is not right. A liquid has a definite mass and a definite volume. That is true. But no definite shape. It takes the shape of the container. So this is wrong. A liquid can be stored even without a container. Can we store a liquid without a container? We cannot. Why? Because a liquid flows from one place to another place. Therefore, a liquid can be stored even without a container. It's wrong. Particles of a gas present throughout the vessel it contains. Yes, it is right. A gas can be stored even in an open container. Can you store gas in an open container? You cannot because it spreads throughout the entire environment. So if you open the lid, what will happen? It will go out. Therefore, a gas can be stored even in an open container. That is not correct. Number 7. A gas has a mass but no definite volume. It's right. A gas has a mass because gas is a matter. It's a form of matter, right? Therefore, it has a mass but no definite volume. This statement is correct. Air particles can be compressed because they are located at a distance. That is right. Okay, children, I explained you when you take air particles, they are located at a distance. They can move here and there freely. Because of that, we can compress air particles. Therefore, air particles can be compressed because they are located at a distance. That is right. A liquid cannot be compressed. That is also correct. Only gases can be compressed. Okay, this is also correct. The things around us can be categorized as matter and energy. That is right. The things with a mass and occupy space are known as matter, and the things without a mass and do not occupy space are known as energy or non-matter, right? So this is correct. Things that occupy space are known as energy. No, here we discuss energy. They do not occupy space. Therefore, things that occupy space are known as energy. It's not right. Did you understand this, children? Wasn't it very easy? I hope you understood this one. We will move to the next one now. Additional exercises 3. Write T in front of the true statements and F in front of the false statements. This is similar to the previous one. Air does not occupy space. Correct or not? It's wrong because air is coming under matter. Every matter occupies space. Therefore, air does not occupy space is wrong. Therefore, you had to write down F. Light does not occupy space. It is right. Light is a type of energy, and energy, they do not occupy space. That is true. Water has a mass? Correct. Water is a type of matter. Matter has a mass. It is true. Air doesn't have a mass. That's false. Air is a type of matter. Matter has a mass. Therefore, air doesn't have a mass. It's false. Heat doesn't have a mass. Heat is a type of energy, and energy doesn't have a mass. That is right. Heat doesn't have a mass. That's true. Sound does not occupy space. Again, sound is a type of energy, and energies do not occupy space. Therefore, this is true. Sound does not occupy space is correct. So, capital T. Sound has a mass? No. Sound is coming under energy. Energy, they don't have mass. Okay? Sound has a mass? False. A stone has a volume as well as a mass. Yes, stone is a solid. Solid is coming under matter. Matter, they occupy space. It means they have a volume as well as a mass. That is right. The space occupied by an object is called the volume of that object. That is correct. That is the definition of volume. So that is true. Matter does not have a mass or a volume. That is not correct. Every matter has a mass and they occupy space. Therefore, it is false. Right? We will move to the next one. Additional exercises 4. Matter is used to make different materials. Mention the materials used and specific properties of them in the following instances. Now, we already did something like this. So, this will be very easy for you all. Okay? We will go through. I have given 3 columns: application, material, property. The first line is completed. Jewelry, to make jewelry, we use gold and silver. What is the special property? Why do we use gold and silver? Because of its malleable nature. We can make different shapes. Right? Number 2, cooking utensils, cooking pans. What do we use? Most of the time, aluminium. Why do we use aluminium? Property, malleable. Malleability. Baby pacifiers, we use rubber because of its elastic nature. You all can do this before me, children. I'm pretty sure you know how to do this. Elastic nature. Next one, application blank. Materials, iron, property hardness. Now we use iron to make different things because of its hardness. What are the instances? To make vehicle engines, to make machine parts, to make vehicle bodies, we use iron. So you can write any of them. I will write machine parts. Iron is used because they are hard. To fill pillows, we use cotton wool. Why? Because it's very soft, because of the smooth texture. Smooth. Right. Then material cotton thread, property smooth. What are the instances we use cotton thread? To make our clothes, to make bed sheets, we use cotton thread. Right? So we will write bed sheets or bed linen. And sometimes towels. Making wires, what do we use? To make wires, the substances we use should be ductile. What are the substances with ductility? Metals. Most of the time copper, aluminium, those type of substances are used. Right? Copper. Ductility. Catapult or slingshot strap, we use a rubber strap. Okay, material is rubber. Because of its elastic nature, you can stretch very well. Roofing sheets. To make roofing sheets, we use clay. Why do we use clay? Because clay can be made into different shapes, right? So here we use clay. Right, children? I hope you understood this one. Additional exercises 5. Fill in the blanks. Here we have a blank. Have a permanent shape that does not change easily. Out of solids, liquids and gases, what type of substance has a permanent shape? Yes, you're right. That is solids. Solids have a permanent shape. Second one, 2 substances, blank here, have a definite volume. What are the substances with a definite volume? Out of solids, liquids and gases, solids have a definite volume and also liquids also have definite volume. What about the gases? They spread throughout the entire container, therefore they don't have a definite volume. Therefore, solids and liquids have a definite volume, right? Number 3, do not have a definite shape. They take the shape of the container. However, they have a definite. What is the answer here, children? That is liquids. Liquids do not have a definite shape. They take the shape of the container. However, they have a definite what? Volume, right? So, liquids do not have a definite shape. They take the shape of the container. However, they have a definite volume. Blank have a definite shape as well as a definite volume. Only solids have a definite shape as well as a definite volume, right? Solids do not have a definite shape or a definite volume. What is this substance, children? Yes, gases. This is very easy now. Gases do not have a definite shape or a definite volume, right? It's very easy, right? Right, the next one. We have to write short answers here. When a metal is hammered, it becomes a sheet. What is this property called? Now I know that you all know this answer very well. What is it, children? This property is known as malleability. What are the substances with this property? Most of the metals. Next one. What is the name given to the substances that can be drawn into thin wires without breaking? That is ductility. Substances like iron and copper, aluminium, gold, silver, they show this nature. What is the property of increasing the length of a material by a force of stretch? It's very easy, like rubber bands, elastic nature. Right? Moving to the next one. What is the name given to the substances with a tendency to break under small force? What is this? Substances like glass, charcoal, they break into pieces under a small force. What is this nature? What is this property, children? Yes, you are right. Brittleness. Next one. What is the name given to the feeling of roughness or smoothness when something is touched? When you touch something, you can feel some substances or some surfaces are rough and some surfaces are smooth. What is this property called? Yes, that is texture. Next one. Due to which special property of rubber is it used to make balloons, gloves, pacifiers? Due to which property of rubber? That is because of its elastic nature, elastic property. Elastic nature. And due to which special property of diamond is it used to cut glass? We all know now diamond is the hardest substance in the world, right? Because of its hardness, we can use it to cut glass. Okay? Here the answer is hardness. Right? We will move to the next one. Right, children. Next exercise. Read this carefully. Take a glass and fill it with water. Then turn it upside down in a water basin as shown in the diagram. You have to fill a glass with water. Carefully turn it upside down. You have to close the mouth of the glass with your hand and you have to carefully turn it upside down and carefully you have to place it in a water basin like this. Okay. Next, insert a saline tube into the water basin. Now this is the saline tube. We will mark it. This is the saline tube. Next, insert a saline tube into the water basin and slowly blow air into water through the saline tube. Now initially, before you blow air into this glass through the saline tube, you will see the entire glass is filled with water. But when you send air through the saline tube, what happens? This air you send go into the glass. What will happen? Air will go up and collect in the top part of the glass. So then what happens when you send air? The water will go out accordingly. When you send more and more air inside the glass, what will happen to the level of water in this glass? It will go down and down. You will understand this very well if you do this experiment at home. You can even do this using a drinking straw. Okay? What can be observed when you do this, children? You can observe air bubbles go up in the glass and the water level in the glass goes down. Okay? So what can be observed when you do this? Air bubbles go up. Where does this happen? In the glass. In the glass. And what happens to the water level? Water level goes down. Water level in the glass goes down. In the glass goes down. Why does this happen, children? Because when you send air through this tube, air needs a space in this glass. But what happens? The space is occupied by water. Therefore, air pushes the water down and air occupies space. So, what is the conclusion? Air needs space. Air occupies space in the environment, right? What do you conclude according to that observation? Air occupies space. Right, children? Did you understand? I hope so. Right, children. Our next question. Look at this picture. This is the same experiment we did in the lab, right? Two air-filled balloons are tied on either side of a meter ruler. This is the same thing we did. The ruler is balanced horizontally by hanging it from the middle. Okay. One balloon was carefully pierced with a pin. What can be observed here? It's very clear. I hope you all remember what we did in the lab. What happened? When we pierced one balloon with a pin, air went out. Let's say that we pierced this one. Then what happened? The other side becomes heavier, goes down. Right? The side with the balloon without air, it becomes less heavy. It goes up. That side goes up. Right? So, what is the observation? The meter ruler loses its balance and the balloon with air goes down. Okay? The ruler loses its balance the side with the balloon filled with air goes down. Right? What do you conclude according to that observation? Now again it's very clear. This side becomes heavier because air has a mass. Now both the sides balloons are there, but in this side no air. This side air is present. This side becomes heavier because air has a mass. So what is the conclusion? Air has a mass. Right? We'll move to the next one. Here we have another experiment that we already did. Okay? A handkerchief was placed tightly at the bottom of a glass and the glass was immersed upside down vertically in a water basin as shown in the figure. Do you remember we watched this experiment? I hope so. So, does this activity make the handkerchief wet or not? What happened? When you immerse the glass like this, did the handkerchief get wet? No, it did not. So, the handkerchief doesn't get wet. Right. Write the reason for this observation, children. Now the handkerchief doesn't get wet because water doesn't go inside the glass. The water doesn't enter the glass. Why can't water enter the glass? That is because even though we can't see, this part of the glass has air in it, right? Even earlier I showed you this one. Now this part contains handkerchief. This is the handkerchief. Even though we can't see, the other part of the glass is filled with air. Okay, so the space in the glass is already occupied by air. So there's no space for water to go in. Understand? So that is the reason. Write the reason for this observation. Water cannot enter the glass due to presence of air. What do you conclude according to that observation? What is the conclusion? Yes, you're right. Air occupies space, right? Air occupies space. Air needs space. Okay, children? Right. Next exercise. 2 activities done in order to find out the behavior of states of matter are given below. We already did these experiments. I hope you remember. Look at this activity 1. Now the same experiment we discussed in the previous exercise. Okay, we have to take a handkerchief. You have to place it in the bottom of the glass, and you have to immerse the glass vertically and upside down in a water basin and observe. What is the next one? You have to light a joystick and you have to fill this gas jar with joystick smoke, and then you have to connect this gas jar with another gas jar. So you have to observe afterwards, right? Question number 1. Look at these things. Write 2 properties of matter. Write 2 properties of matter. What are the properties of matter, children? Yes, there are 2 main properties of matter. Matter has a mass and matter occupies space. We will write that. Matter has a mass. Matter occupies space. Occupy space. Okay. Next one. Mention the main physical states of matter. How many states of matter present? Yes, 3 states of matter. What are they? Solids, liquids and gases. Okay. Number 1, solid state. Number 2, liquid state. And gaseous state. And the next one, which property of matter is shown by activity 1? This is activity 1. Now we did this experiment to show that air occupies space, right? So we know that when we immerse this glass in water, water doesn't enter the glass. That is because of presence of air. Okay, so by doing this experiment, we can come to a conclusion that air occupies space. So which property of matter is shown by activity 1? That is that matter occupies space. Which property of matter they ask. Therefore, matter occupies space. Okay. Write down a property of matter that can be identified using the observation spreading of smoke through gas jars. Okay. Write down a property of matter that can be identified using the observation spreading of smoke through gas jars. Now smoke is coming under gases. Now when we connect these 2 gas jars, initially smoke was there only in 1 jar. So when we connect these 2 jars, what happens? The smoke spreads through both the jars. Why does this happen? That is because air, smoke, or we can say gases do not have a definite volume. It spreads throughout the entire container. Okay? Write down the property of matter that can be identified using the observation spreading of smoke through gas jar. Okay, so here we can come to a conclusion. Gases do not have a definite volume. Right? Understand, children? Gases do not have a definite volume. Okay? I hope you understood this one. What is the name given to the tendency of glass to break under a small force? Now, this is very easy. What is this property? That is brittleness. Brittleness. Right? Mention the materials used and specific properties of them in the following instances. Now, we did many examples like this. This will be really easy for you. So, we have a table, application, property and materials used. The first application, tires of a vehicle. What is the materials used? Rubber. Because of which property? Because of elastic nature. So, property is elastic nature. Materials used is rubber. Next one, cutting glass. What is the solid substance we use to cut glass? Yes, that is the hardest substance. What is that? That is diamond. So, why do we use diamond to cut glass? That is because of its hardness. So, property is hardness. Material, diamond. Diamond is also used to make jewelry, right? Okay, we'll move to the next one. Next exercise we have, many of the things that catch our eye are matter, and energy is with our lives from morning till we go to sleep at night. What is the main source of energy? What is the main source of energy, children? Even in the last lesson, I explained you that main source of energy is, what is that? Yes, that is sun. So, the sun gives us the heat energy and light energy. So, plants can do photosynthesis because of the solar energy, right? So, the main source of energy is sun. Next one, define what compression of gases is and write 2 examples for that. Now, what is the compression of gases? I hope you remember I told you gas particles present far away from each other. Because of that, using an external pressure, we can reduce the volume of these gas particles, right? We reduce the volume occupied by the gas particles, that is known as compression. Okay, so what is compression? Reducing the volume of gas. Volume of gas by applying pressure. Right. Write 2 examples. Examples also we discussed. What are the examples? To fill oxygen gas into cylinders, to fill LP gas into cylinders. I hope you remember these things. To fill oxygen gas into cylinders. That is the first example. Second one, to fill LP gas into cylinders. Right. Mention the hardest substance in the world and write 2 applications of it. What is the hardest substance? Now, this is really easy. That is diamond. And 2 applications. We use diamond to make jewelry and to cut glass. So, 2 applications. to make jewelry and to cut glass and even gems. To cut glass. Okay. Write 2 main ways of generating electricity in Sri Lanka. What are the main ways of generating electricity in Sri Lanka? Now, electricity is a type of energy, right? There are different ways we generate electricity in Sri Lanka. Using hydropower. So, in hydropower plants, using the energy of water, we can generate electricity. What are the other ways? By thermal power plants, using the heat energy. By burning coal, heat energy is produced. Using this heat energy also, we can produce electricity. And even by solar energy, right? So, what are the ways? Using hydropower. Solar power, solar energy, thermal energy, thermal power. Right, children, did you understand this one? I hope so. Write 2 metals used to make jewelry and mention a specific property of them. What are the most widely used metals to make jewelry in jewelry industry? Yes, gold and silver. We will write gold and silver. Mention a specific property of them. Because of this malleable nature, we can make different shapes because they are malleable. What is the meaning of malleability? Malleability means the special property of these type of metals that they don't break when we hammer them. When we beat them with a hammer, they don't break. Instead, they turn into thin sheets. Okay, so the special property is malleability. Right, children? So we completed the lesson and we did a lot of exercises. I hope you understood this lesson very well now. Okay? So at home, you have to practice all these exercises again and again so that you will understand this lesson very well. Okay, children?